Hello, I'm Karl Ricanek, and I'd like to welcome you to IEEE IAPR International Joint Conference on Biometrics for 2011.
Biometrics is the science of establishing human identity based on physical and behavioral attributes of an individual. So what it entails is the fields of pattern recognition, computer vision, image processing, statistical analysis, and to some extent even medicine, biology. So the exciting thing here is a student who is considering a career in this field is likely to be working at the intersection of multiple topics. So for example, if a student is interested in working in biometric privacy or security, again, that straddles multiple different fields. Cryptography, for example, and then you have pattern recognition. So there are so many exciting problems in this field which are yet to be solved. Another example, if you consider the problem of human recognition in a non-ideal environment, in an environment that is characterized by harsh lighting, changes in pose, motion blur, etc., classical biometric systems may not operate very well. So here is an opportunity for a student to come in and take this problem and design algorithms and methods that can perform human recognition in such challenging environments.
Well, in my team, we have been working on quite significant national projects on biometrics identification. In 2005, our technology has been used in immigration control between China, Shenzhen, and Hong Kong border, and also in Beijing 2008 Olympic Games. Our technology was used for ticket verification, that's for authenticate the ticket holder. And also in Shanghai Expo 2010, our technology has been used for security guards for key areas.
One of the things that I've been recently looking at is to provide real-time face recognition and facial expression capabilities to blind people. Okay? Now, I have an undergraduate team called the Gemstone team in Maryland. We take the best incoming students, about 200 of them, something like that, and divide them into many research groups. And one of the groups I have been mentoring from 2009, and this is my last year, they'll be graduating in 2012. They are building real-time facial expression devices and face recognition algorithms using a camera mounted on a cane. We actually talk to folks at the National Federation of the Blind, what is the best way, where should we put the camera, right? On the head or over the eyes or on a strap of a backpack, anything like that. So they said, well, let's try it on the cane because we always carry it with us and so on. So my students have nicely built that device, and they also built a bunch of algorithms using existing SDKs. I mean, these are undergraduate students, so they're not completely aware of everything that goes in computer vision, right? So that's okay. And now they're doing experiments with blind people to see if having such a device would help them in improving their communication skills. If I'm a blind person, if I'm talking to you now, I have no idea whether you are looking at me or whether you're sticking your tongue at me or you are just, scowling at me, right? So I don't know that. So if I can give a real-time feedback, then maybe it will change the way I talk to you.
Well, it'll be good if I could just walk into a conference and the sensor that is attached to my clothes can scan the room and tell me where everyone is located and identify a person and then remind me that I had to meet that person in order to convey something to them that perhaps I have forgotten. So this automatic human recognition can be combined with some other applications as well. Very often when I see someone in a conference like this, embarrassingly, I may have forgotten their name. And it'll be nice if I have a sensor placed in my glasses that can scan that individual and then tell me through my earpiece that this is Chuck Wilson, and hopefully that information is going to be useful in having a more productive meeting and also a more socially acceptable interaction. And by having more powerful computers, one can certainly search through large databases in order to perform, say, face recognition or iris recognition. And so the architecture of the machinery is very important because it imparts speed. But there are also other aspects, specifically with respect to the sophistication of sensors. Some of the face scanning cameras, iris cameras, have improved substantially over the past few years. And this means you can potentially obtain face images or iris images at a distance and process it successfully. Again, it's a research problem. However, with improvements in sensor technology, in the very near future, we can potentially do face and iris recognition at a very large distance.